Hello chemistry champions, and welcome to the channel where we solve chemistry problems. My name is Werner. In this video we will be looking at solving for the value of X, which is embedded in a chemical formula. By the end of it you will know what the number of ammonia molecules is that bind to a central copper atom. There will be two methods that we'll be looking at. The one method is rather short and is somewhat counterintuitive, and the other method is a bit longer and relies more on chemical principles that you will be familiar with. So with that said, let's have a look. So today we want to ask the question, what is the value of X in this particular copper complex? And we are told that the amount of ammonia equals 29.9%. Before we get started, we can agree that for the vast majority of copper 2 plus complexes, either has a tetrahedral geometry or an octahedral geometry, and that would correlate to either X equals 4 or X equals 6. And that is before we've done any kind of calculation. That is just in relation to what we know about the chemistry of this particular compound and of copper 2 geometries. And so I'm just pointing that out because if you find a value of X that is, say, 10 or 1 or 2, then it is unlikely to be the right answer because there are no such copper compounds known. So with that said, let's look at the first of two methods that one can use to solve it. If you want to try to solve the problem yourself, pause the video now and give it a shot. Right, so the first way one can do this is to simply take the ammonia and use it as a ratio to whatever chemical species are left in the formula. This ammonia is the one that is the unknown, and so the rest of it is the copper sulfate in the particular formula. And we know that 29.9% is in that particular formula. That means that 100 minus 29.9%, which is 70.1%, is what's left and what is the percentage of the copper sulfate. The next step is to divide these values by the respective atomic weights of the chemical species. So for ammonia, we know nitrogen is 14 atomic weight. Hydrogen is 1 times 3. That gives 17. And for copper, the atomic weight is 63.5. For sulfur, it is 32.07. And for oxygen is 16. But we have 4 oxygens. So just keep that in mind. 4 oxygens there. So if one add up all of this, you have 159.9. So that can go here as the denominator. And if one now do this division, here you have 1.76 as a ratio to 0.439. And we know the rule is typically that you divide by the smallest denominator. And that means that the answer here is 4 to 1. So we can see that for ammonia, the X value equals 4. So that is the first method that one can do it. It's quite quick and dry, and it relates to finding a ratio between what is the unknown and what is the known. Now the second method one can use to find the value of X in this problem is to find the mass of ammonia in 1 mole of the complex, in other words finding the molar mass, and that is simply 14x plus 1 times 3 times x, and that is 17x. X because of the ammonia that is the value that one wants to find. The next is then to find the total mass of 1 mole of the particular complex, and that is then adding all the atomic weights together. So you have 63.5 for the copper, 14x for the nitrogen, 1 times 3 times 4 for the hydrogen, 32.1 for the sulfur, and 16 times 4 for the 4 oxygens. That gives a value of 159.6 plus 17x in grams. And finally, one then look at what is the percentage of ammonia in the complex, and you do a division. We have calculated that it's 17x is the molar mass of the ammonia in the complex, and you divide that by the total number of atomic weights known, that's been calculated, yeah, multiply with 100% equals 29%. So notice the difference between this method and the previous method. In this method, you work less with the ratio and more to do with the mass of the different chemical species, which you then set on one side and compare that with the known value of ammonia. And then it's simply a matter of solving for x. 17x times 100 is 1700x, and each of these denominator values then gets multiplied with the 29.9, which gives you 1700x equals 4772 plus 508x, and that gives 1192x equals 4772, and that gives x equals 4. So that is a second way in which you find the same answer for x equals 4 as the value of ammonia in that particular copper complex. And there you have it, solving for the value of x by two different means. Let me know in the comments if you found that of value, and or if you solved the problem by another means, or if you got the same answer. Also remember to subscribe to the channel for similar content, and stay curious. Thanks for watching, and I'll catch you in the next video. In this last portion of the video, there's a bit of a bonus for YouTubers who stay to the end, because I happen to have some of the relevant chemicals in my lab to show you the preparation of the tetraamine copper 2 complex, for which you have just solved for x. So now we know that x equals 4, and we can set up this balanced equation so you can get more or less an idea of what we're trying to do. This is the reaction that's taking place with the hydrated water molecules in the copper starting material, the pentahydrate, but it's not shown in the products because those hydrated waters simply become part of the solvent. So you start by adding about 4 grams of copper sulfate pentahydrate to a beaker, and to that you then add about 2 milliliters of a 60% ammonia solution. Recall that when we say 60% ammonia solution, we are simply saying 60% of ammonia gas that's dissolved in water, typically designated with an AQ sign suggesting an aqueous phase. But once this is added, the beaker with the deep blue solution is placed in ice, while about 15 milliliters of ethanol is added dropwise, and the solution, which starts to show some precipitation of the product, is stirred and swirled from time to time. After that, let the mixture stay in the ice for several hours, as this will increase the amount of precipitate and hence improve the yield. The mixture is then filtered using a Buchner funnel and a simple vacuum system. The filtrate is more or less colorless, while the precipitated product is washed with cold ethanol and cold ether to aid with the drying process of the solid. And the salt can then be dried in air, and the percentage yield can be determined. And there you have a lovely deep blue copper 2 complex.